And another pattern that we are going to discuss here is the adapter pattern. An adapter pattern is this. So we have another scenario. So your bank A has a plan to interoperate with bank B and C and D, right? And that always happens. For instance, the 우리 bank has to interoperate with like the 농협, and it has to operate with the city bank and so forth, right? And each bank has slightly different specifications in the transactions because they all have different systems. And then in your code, many times you have to access bank B and C and D, and what happens is that you have this superclass or base class, and then you use this bank B transaction managers, bank C transaction managers, bank D transaction managers. And this is the separation between our clients and the other banks. Okay? And then whenever we have to deal with the bank B, C, D, and if we add bank E, then we have to add another class like this, right? And then how to do that? Whenever we have to do something, right? We have to do something. What we are going to do is that and before we go further, I forgot to explain one thing. And then within the bank A interoperator, in one of these function, there will be the if else compound. If we are dealing with bank A, then bank B, then we use bank B transaction manager. If we are dealing with bank C, then we are going to use bank C transaction manager. And if we are going to use bank D, we are going to use bank D transaction manager. So we have this if-else compound, right? That's what we are. That's the obvious solution. Okay, so the solution for the previous problem of the if-else compound is this. What we are going to do is that we are going to create the abstract adapter class like this, and this adapter class is going to sort these things out, like the if compound. We are going to put this if compound here in the transaction adapter, and this will take care of this many outside transaction managers. And then whenever bank A has to do something about that, what it handles is the transaction adapter only. So means that previously this bank A interoperator, whenever happens to use the bank B, C, D, it had to have this if else if compound many times. But here transaction adapter has one time, and bank A interoperator is going to use this one time definition many times. Okay. So many developers for bank A needs only to handle transaction adapter class, and few developers will develop adapters because it is just only a wiring job. Wiring job means like this. Okay. So there is two types of adapter like this: the object level or class level that we are not going to cover in this case. So this is more like object level case, or the case of the adapter. So that's what is so far. So actually it was a huge week 1 and 2, right? So week 1 and week 2 and even week 3 and part of the week 4. 4, like the half of the week 4, we spend these times to cover programming in MATLAB and UML and design patterns. Because previously this course was known as a programming class for the industrial and systems engineers, and that's why I'm putting so much emphasis on this week 1, week 2, and week 3. And the reason why I'm putting this upfront is that actually what you are going to do is in the rest of this class is that you are going to program many times. You are going to implement many different programs. I don't want to teach you UML or design patterns later, because that these are kind of standard that you are supposed to like keep up, right? And these programming patterns and programming like styles and programming methods you always have to use. So if you want to be a better designer or better kind of solution providers or sometimes better programmers, then you have to learn these things, I think that in my opinion, upfront. And then later, you can use your industrial engineers' knowledge about the statistics and algorithms and dynamic programming and so forth. Then these are substance. And we still have many weeks, then we will cover this, and the main focus of this class is that point. But also a subside of this class is that making you to handle these kind of complex problems with software artifacts, and and to design these software artifacts, you need to learn these things. So then, okay, so we are done for the programming parts and software design parts. I wish that you use this knowledge in the rest of our class and in the future. And then from the week 3, the slide set of the week 3, we are going to more focus on the algorithms and data structures. Okay, nice work, and we are going to see you in the offline class. Okay, bye.